This lecture is about concept of a derivative. We need differentiation in machine learning. At least we should have concept of what differentiation is. So if we begin, let us begin with this example. That is, if you look around in your world, you will find that many things in this world are related to each other, in the sense that when one changes, the other also changes. For example, take the example of, say, let me show you some pairs of things which depend upon each other. Say you have here, suppose, first example, that is marks that you obtained in your examination. That depends upon the time invested by you in preparation. The more time you invest in preparation, the more marks you will get. This means that marks obtained depend upon time, invested time. Number one. Number two, for example, similarly we can think of like this. We can say taller people tend to have more weight. That means weight and height. Then there is say, for example, sales of ice cream. A shopkeeper sells ice cream. How many does he sell? That depends upon the temperature. If temperature rises, people register a higher sale of ice cream. So sales of ice cream depends upon temperature. Similarly, we can have, say, for example, how much salary do I obtain? That depends upon my experience. With the passage of time, the salary of an employee increases. And so many. There are many such pairs. It would be wastage of time if we go on writing all those. We cannot. That is simply not possible to write all those. But these few will serve the purpose for which I have listed them here. But yes, of course, first thing that I would like to tell you is that since these pairs are different, here you have marks, here you have weight, here sales, here salary, we will do one thing. What is that? We'll call these variables on this side, we will call them y, and we will call them x on this side. Y will then denote that variable which depends upon this variable. This variable is called dependent variable, and this variable is called independent variable, because it is marks depend upon time invested, not the other way around. Similarly, weight depends upon height. Sales of ice cream, they depend upon temperature, not that temperature depends upon sales of ice cream. Similarly, salary depends upon experience. So this is called dependent variable, dependent. Y is dependent variable, dv dependent variable, and x is independent variable. So from this example we will learn that there are many things which depend upon each other. Well, why is this important? Because when someone depends upon something else, say y depends upon x, we write it as y function of x. Y function of x means simply y depends upon x. So if x changes, y will change. Depending means, the test of dependence is that if you change this variable and then see that this also changes, this is the dependence. If you change this but this does not change, they are not dependent. Okay, now y and x, we will treat y for all these dependent variables, and the x for all, whatever we derive, that will be true for all these variables and these variables. But most of these examples are a little bit complicated. In the sense, see, for example, marks obtained by a student depend upon time invested, but it also depends on many other factors. For example, the standard of the paper. If the paper is too difficult, then marks obtained will be lesser. Similarly, weight of a person depends upon the height of that person, but again, this is not necessary that if height increase, weight will increase. Not necessarily. So sales of ice cream, they depend upon temperature, but they also depend on many other things as well. So these are a little bit, all these examples, they involve something more than what I want to in this lecture. I want just something that depends upon only one thing. I will ignore those other things on which these depend, or I can adopt. I can, instead of them, I can illustrate the same thing by a simple, very simple example, that is that of a distance traveled by a car. When a car moves, it travels distance. Suppose there is a car coming from here, and you are near the road here, not on the road, on the side of the road, and then there is another friend of yours that is here. These A and B, they represent 2 points on the path of the car. As the car moves, it passes through A, it passes through B. As the car moves, it covers distance. How much distance does the car cover? That depends upon the time taken by the car. If the car moves for a given speed, if the car moves for more time, it will cover more distance. If the car moves for less time, it will cover less distance. The same is expressed by this S. Distance traveled by the car is equal to ft. Now the interesting thing, that means in place of y we have s here, in place of x we have time here. One of the best examples to start with, and see, distance travel depends upon the time. The more time you allow this car to travel, the more distance it will cover. So let us do one thing. When something depends upon something else, and when you change that something, this also changes. As an example, let me go to this. Suppose we have y is equal to 3x, and now if you allow values of x like this, put x equal to 0, y will be 0. Put x equal to 1, y will be 3. Put x equal to 2, y will be 6. Yes, of course, 6, and so on, and so on. So what you find? You first, by x was 0, then you changed x to 1. From this stage to this stage, how much did x change? The change in x, that is registered as delta x. This symbol delta means change. It's different from del that I used it in one of my lectures of machine learning. That is gradient. This is change. We will discuss this at a later stage, not in this lecture. Not in this lecture. So delta x means change in x. When x changes from 0 to 1, the change is calculated by taking difference between these two values. That means 1 minus 0. You will have to calculate 1 minus 0. 1 minus 0, that is 1. Okay, that is 1. Now if you this is the change in x. The corresponding change in y is 3. Change in y is 3. Corresponding change, I say. Similarly, if x changes from 0 to 2, this change delta x equal to 2, this change from 0 to 2 is gives us a total change of 2. X changed by 2 units. The corresponding change in y is 6 units. Change in y is equal to 6 units. So again, change in x equal to 1, change in y equal to 3, change in x equal to 2, change in y equal to 6. That means y changes with x. Y changes with x. When something changes with something else, we have a rate of change. Where there is this dependence, there is rate of change. What does rate of change mean? Rate of change means how strongly y changes with x. What does that mean? How strongly y changes with x? I will tell you. How strongly y changes with x. Here, what does that mean? That means this. When x, see, in this example that I gave, when x, just forget about this example for a moment and concentrate on this value. Oh, sorry, I should not delete it. Rather, I want to actually enclose it with, say, this. in this relation, what we found, when x changed by 2 units, y changed by 6. Instead of this, suppose I had now this, instead of this I had this relation, y is equal to not 3x, I had y is equal to 4x, and see what will happen. X, y, x0, y0, as like this, as in this, x1, y4, 4 ones are 4, x2, y8, 4 2 is 8. Now calculate here. Suppose x changes by 2. Let's take this and this. X changed by 2, delta x equal to 2, as we did here. X changed by 2 here. How much does y change by? How much change occurs in y? Let us see. From 0 to 8. That means change in y is equal to 8 minus 0, that is 8. So what do you see? You see that in this relation and in this relation, when you change x by the same amount, by how much amount did you change x here? By 2 units. You changed x by 2 units. And how much did you change y? X here, you changed x by 2 units. How much did y change here? 6. How much did y change here? 8. What does it mean? It means that this y depends upon x more strongly than this y depends upon x, because y here changed more with the same change in x as it changes here. The change in x, when you compare two rates of changes, when you compare two rates of, you compare rate of change of this and rate of change of this, what you have to do? You have to change x by the same amount. You change x by the same amount, and then look at the corresponding change in y. Where y changes more, rate of change is more. Where y changes less, rate of change is less. So in order to compare two relations, which of the two is stronger? Say, suppose for example, you have here father, this is son father relation, and here this is son mother relation. So it is something like this. Then what is happening? If the reverse, I should write it in reverse. This is father son relation. That means father depends upon son. What does that mean? Father depends upon son. If something happens to the son, God forbid, if something untoward happens to the son, it is as if the same thing happens to father. Father feels it, he's shocked, he feels, but this mother son, if something happens to son, mother also feels, but mother feels more than father. Mother feels more than father. This is what, of course, these are only these generalizations. There can be exceptions as well. There are exceptions, but I will not go into that is not my topic. I'm using this as an example. I say that if a relation is stronger, it means that it's like mother-son relation. If it is strong, very, very strong, it's like mother-son relation, you will see that this is not the end of the dependence. You will find very, very exciting relations that God has created in our world. Exciting relations that God has created. One of them, the fastest, that is called exponential relation. We will go to those relations at their due time. Okay, now till then, what we conclude from this? In our world, there are many things in which one thing depends upon the other thing. Like here, y depends upon x, but two different relations can have two different dependencies. In one relation, there is stronger, this weaker dependence. Then another relation, there is stronger dependence. How do we calculate this dependence? We let the independent variable, that means x. Let's keep, in order to make this simple, let us call independent variable is x. So we will directly call x. Let us. We have what we do. How do we calculate? How do we compare them? We let x change by the same amount. And then see by how much amount y changes. In case the relation in which y changes more, that relation is more, that's more strong, that is stronger, rather not more stronger, that relation is stronger. As we found in case of these two relations, we found that this is stronger dependence than this. But one thing that you must have now noted, that is, for this to decide, for you to decide which of the relations is stronger, you have to take equal change in x and then compare these. How much amount of x, by how much amount we let x change here and here? In my example, I let x change by 2 units, I let x change by 2 units in my example, but you could change that. And we have made it a standard now that we let, in order to compare which relation is stronger, we let x change by 1 unit. 1, you see, taking something equal to 1 is the easiest thing that you can do. For example, if you go to a shopkeeper and tell him what is the rate of the onion, you mean what is the price of 1 kg of onion. If you go to a milkman and ask him what is this rate of milk, he will say it is 50 rupees per liter. So 50 rupees for 1 liter. Where there is this rate word rate, there is 1. Where there is rate, there is 1. So let's go back to our this just one. Okay, so instead of taking delta x equal to 2, what do? We take delta x equal to 1, delta x equal to 1. That does not mean you are banned from taking delta x equal to 2. You can take delta x equal to 2, but then later from this, for example, even if you use this, even if you use this, I mean this value, delta x equal to 2, no problem. But do one thing. What? See what you have to do. Then divide delta y by delta x. Why? This will give you change in y per unit change in x. How? You can see yourself. Take the change in y. What is change in y here? That is 6. That is 6, sir. Divided by change in x, corresponding change in x, that is 2. 6 by 2, that is 3. So see, if you had changed delta x by 1 only, you would get a change in y equal to 3. That is proved, evidenced by this. When delta x is changed by 1 unit, delta y changed by 3. So you have two methods. Either you directly change x by 1 unit and find by how many units y changes, or you do let x change by any number of units, but then divide the total change in y by that number. And if you do that, this is the same thing as if you are changing x by 1. So what is delta y by delta x? Delta y by delta x is change in y, change in y, change in y. It is change in y due to a unit change in x, Sometimes you may wonder, sir, there is no unit, sir. I have not written that delta x equal to 1. The mere act of this division creates delta x equal to 1 in the denominator. How do I know? Yes, you can check it. Suppose you have 6 by 2. Automatically 2 1s are 2 3s are. This becomes denominator is always reduced to 1. But then you will object. You will say, sir, suppose it had been not 6, it had been say 7 divided by 2. Can you reduce it to this 1? Yes, of course. I will do this. See what will I do. I will divide 7 by 2. That will give me 3.5 divided by 1. That means as if I have used a fractional table. So it is again any number can be reduced, any denominator can be reduced to 1. So look at this denominator as if it is 1, and change in y due to a unit change of x. See, first let me get rid of this. I mean this not yes, this whole thing, so that space is cleared here, and I delete it. And see, delta y by delta x is then change in y due to a unit change of x. Okay, and this has a name. It is called rate of change. The word rate of change, rate of change of y, rate of change of y with respect to x, with respect to x. Okay, with respect to x. Why rate of change? Because this is 1. Rate means for 1, value for 1. Where is value for 1 here? Because it gives you value for change in y. When x changed by 1 unit, you take unit change up. That is what you have in market. Rate of onion, that means price of onion per kg. Rate of milk, price of milk per liter. Rate of say these eggs, that is per say tray or per dozen or per egg itself, per one, that means 1, and this is the rate of change. Now that's okay. I think you have understood it clearly, but then there is a problem. What is that problem? If you take y is equal to 3x, or you take y is equal to 4x, or any relation which is linear, like say for example linear means x, this independent variable has power 1, both are having power 1. Now if you have a relation of this type, and you want to calculate rate of change of this or this, for calculating rate of change, what do you need? You need two changes, a change in y, a change in x. And then how do you calculate rate of change? By dividing change in y by change in x. Okay, now if you start with this for example, you need a change in y. How much change in y will you take? Any change in y will do. Any change in y, greater or smaller, it will not matter. And what will change it? The corresponding delta x is basically you first decide delta x, how much you will change x. That will decide how much y will change. In case of these relations, it does not matter how much you let x change, how much you let y change. It does not matter there. So let's see, is it true what Sari is saying? Yes, of course. We can always check. This is x, this is y. Say I take x equal to 1, y equal to 3, 1s are 3, x equal to 2, y equal to 3, 2s are 6, x equal to 3, y 3, 3s are 9. Let me take these two values. First, let me take these two values. What is the change in x? Change in x from this to this. Exactly 1, x changed by 1 from this to this. What is the corresponding change in y? Delta y is equal to 6 minus 3, that is 3. Okay. 6 minus 3 is 3. Now, what is rate of change? If I calculate now rate of change using these, delta y by delta x, that is 3 by 1, that is 3. So let me do one thing now. Let me now take these two. If I take these two, what is the change in x? 2, because 3 minus 1, that is 2. What is the corresponding change in y? 9 minus 3, that is 6. Delta y is equal to 6. Divide now delta y by delta x, that is 6 by 2. 6 by 2. What is that? 2 1s are 2, 2 3s are, you can see. It doesn't matter. The size of the change taken does not matter. This does not matter how much you let y change, how much you let x change. But just have a look at this now. Y is equal to x square. Look at this. And then you have xy. Suppose x is equal to, first x is equal to 1. 1 squared, that is 1. Y is 1. If you now let x equal to say 2, y 2 squared will be 4. If you now let x equal to 3, y square, y will be 3 square, that is 9. Okay, 1 2 3. That is this is how it works. 1 2 3 and y is equal to this. Suppose I now take this change in x, delta x. How much it is? 1. How much is the corresponding change in y? 4 minus 1, that's 3. 4 minus 1, 3. Now calculate rate of change using these two values, delta y by delta x. That is 3 by 1. 3 by 1. Okay. Now suppose you take these two. 3 minus 1, that is 2. Delta y is equal to 2. And 9 minus 1, that is 9 minus 8. So delta y is 8, delta x is 3, therefore delta y by delta x is equal to 8 by 3, that is not equal to 3. You can divide 8 by 3, of course, but you will not get 3. This means that this is a relation where rate of change changes. It does not have a constant rate of change. Its rate of change changes. And how to calculate then? And if rate of change changes, if you can have more than one rate of change for a relation like this, then how is rate of change meaningful for such relations? Yes, we make it meaningful. That is why calculus comes. Calculus is needed for these changing rate of changes. This is your first video of this. Then we will go for another video. But first, let these things be absorbed by your mind. Thank you.